good evening, or morning, or day, or whatever it is. It's evening for me. I want to do a quick video on special forms. I lied a little bit this week to my students, and I apologize, because I told them that difference of squares is really the one to memorize, and to me it is. Difference of squares is the most important one, because perfect square trinomials you can factor regularly. Sometimes it'll take you longer than if you recognize the pattern, but for most students, unless you are really like pattern oriented, it's not going to be a pattern that you need to have memorized necessarily. But if you are working in a class or in a system where there's a lot of cubing happening, then you might want to also learn the cube pattern. So difference of squares is, like I said, to me is very, very important, because it's that one where it is annoying to factor, like really annoying to factor any other method. So the way you can tell it's a difference of squares is the first term is a square and the second term is a square. Now, it could be bigger than a 2. The idea is it has to be a number you can split evenly. So you could have 4s here, or it could be something that is a number to the 4th power. It could be 6s here, because 6 will split into 3 and 3. It could be 8, because that'll split into 4 and 4. 10 will split into 5 and 5, and so on and so forth. All right, because that's the problem with cleaning the board, though, is it gets squeakly. All right, but so the idea here is to get your answer, or to factor this, you take the first term and square root it. Notice it doesn't have a square anymore. And then you take the second term and square root it. And then because the middle term, which should have been like not squared, it should have been like an AB power, is gone, it means that one is positive and one is negative, because the middle term will disappear. All right, so that's the generic like math, like that's what the pattern looks like. So let me do an example. All right, producer, will you pick a squared number that you know?
4. Sorry, brain's slow.
I love you, but gosh, that was boring.
I know.
I'm gonna go 64.
Ooh.
Yeah, that's
Not
right.
Boring.
Okay, well, I want it to be a little bit bigger and challenging, because you're not always going to see small numbers. All right, so the first pattern you look for is when you see 2 terms like that, you want to say, oh, it's 2 terms. Are they squares, and are they minus? If they are a plus, then you can't use difference of squares. You could look for GCF. It might be prime, which means not factorable. But in this case, 4 is a perfect square. X squared is a perfect square. Ooh, let's get challenging. Let's do a 4 there. Oh, you know what? Let's not make it too challenging. Look at me changing my mind all the time. All right, and then 64 is a perfect square, and they're connected by a minus. So you square root 4x squared. 4 square rooted is 2. You also get a negative 2, but we're not going to include that one in this particular answer, just because it's not necessary. And when you square root a square, they're opposite operations, and this little invisible index of 2, you take 2 divided by 2, which leaves you with 1. All right, the square root of 64 is 8. If you don't know that, use a calculator. And then what happens is the 2x goes into the front, because that 4x split. The 8 goes into the back, because the 8 split, and then one has to be a plus and one has to be a minus. Does not matter which one is plus and which one is minus. For some reason, I have a tendency to default to plus minus, but it doesn't make a difference. If you're not sure ever that you did that right, you can multiply them back together to make sure that you were correct, which you were, because you're very smart. You did a great job. The reason I did that fast is because hopefully by this point you know how to multiply, but if you don't, I have a video on that. But what I wanted you to see is that this is a positive 16x and this is a minus 16x. So what happens is 16x minus 16x goes to 0, and that's why when we had the original, we were left with just the 4x squared and the negative 64. Okay, so that's difference of squares. Now, perfect square trinomial has 2 formats. You can have the positive version and the negative version. They call it a perfect square trinomial because it's made up of a perfect square. You can also do different solving with that, so sometimes it's nice to be able to do that. So when I show completing the square, I do a completing the square video. This is a nice format, but once again, you can just factor it or see the pattern in completing the square. What generic math will tell you is that the factors of this are a plus b squared, what that really means is a plus b times a plus b, and then what that looks like is you'll get an a squared, you'll get a 2ab, and you'll get a b squared, and because that one is positive, they'll both be plus. This is a harder pattern to remember because people will recognize the squares, but then what you have to do is you have to take their square roots, multiply them together, and then double them, okay? So it's kind of one of those things where, like I said, if you're good with patterns, it can be easy to recognize, but for some people it's a complicated pattern, okay? For the negative, you get a similar process, and you get a very similar answer. You'll get the a squared, the 2ab, and the b squared, but there'll be a negative and a plus. Why a plus at the end, you ask? Because when I take negative times negative, it goes positive. Now let me show you that in action. Real basic one. Is that a real basic one? No, that's not a basic one. That's just squared. Oh my gosh, no, that was fine. Oh, Siddig. Okay, it fits the pattern because the square root of x squared is x, the square root of 25 is 5, 5 times x is 5x, doubled is 10x. Okay? So those are kind of the most common that you'll see in an Algebra 1 level. If someone is being nice in Algebra 2, you'll see that in Algebra 2 as well. So what you'll get is you'll get that perfect square number, and then the middle number will be, like, that's 8, so 8 doubled is 16. So square root of 64 is 8. 8 times x is 8x. 8x doubled is. Okay. All right. I don't even think that much of it that I am great at explaining it. I apologize. But like I said, it's just one of those things where if you spend a lot of time factoring, it's totally worthwhile learning. And if you, like I said, if you're a person that's good with forms and with patterns, then it's a great pattern to learn. But what's nice about it is, and these are small examples, but even bigger examples, you can still factor this regularly. You could say, okay, what factors are there of 25? What will make them add to 10? Okay, so it just, that's why I don't, it's not a bad form, but it's to me, it's not the most important. Okay, now, cubes are a little strange. I'm going to look at just the plus one first. So a cube form happens because you have a cubed term in the front and a cubed term at the back. These can be harder to recognize because people don't necessarily know cubed numbers off the top of their head, but I will tell you, textbooks are fairly lazy and teachers were tired. So we have a tendency to use the same numbers. So 1 is a cube because 1 cubed is 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. I did not have those memorized till I was a teacher, and the only reason I had them memorized is because I saw so many problems where they used those pieces for the cubes, especially when you're teaching like radicals and roots and stuff, that you just you see them so often that they just kind of get stuck in your brain. So they will go bigger than that, but not as often. So it's kind of like if you happen to have the first couple of memorized, it'll be fine. If not, use a calculator to find out if it is a cube. All right, so the pattern then becomes the cube root of the first number and the cube root of the second number. Then you take the cube root of the first number squared, the cube root of the second number squared, and then the middle term becomes those two just multiplied by each other. So it weirdly looks like a perfect square trinomial, but it is not because the middle term is not doubled. Now, you might notice I did not put signs in there. That's because the way that, and some genius, good for them, told us or taught us how to remember this is they gave us SOAP. So SOAP is an acronym. It stands for same, opposite. Oh, one of my students today, it was awesome. When I said opposite and then I said A, he said adjacent. Which I was like, that's brilliant, because it just means that the trig was so ingrained into his brain that even though it wasn't what I wanted, like, it was nice to see that, like, in his brain it was still there. So that was like, I liked it. So good job. So when I say same for this first one, it means the same as the original sign. So if the original sign is a plus, then you get a plus here. So in this version, it's still the same format. but your same in this case would be a minus. The next term is going to be your opposite, so if it was a plus, it goes minus. If it was minus, it goes plus. And then AP is nice because you don't have to think about what anything else was. It is always positive. All right, so let me show just a couple of examples of this, and you will see how I use the numbers that I had on the board earlier as like, oh yeah, hey look, she's being a lazy person and not bothering coming up with fancy cubes, because I'm not going to come up with fancy cubes. All right, so let's do 64x to the third, I don't know, plus 27. Yeah, we'll keep it there. All right, so if you're not sure if 64 is a cube, you go ahead and you cube root it on your calculator. What I like to do is I like to, it's kind of a fun little technique. I like to cube root it as my first step to make sure that it is a cube. And then it's like a bonus because once I know it's cube rootable, I already have portions of my answer. So the cube root of 64x to the third is 4. And then remember, I said you take this power. Oh, that was a totally different video. You're not watching them all. It's because I said it tonight. So I feel like you already watched this, fools. But you're not fools, and I'm just tired. When you have a power and you take a root of it, that number is called the index. And what you do is you divide the power by the index. So 3 divided by 3 is x. And I'm sorry, I really didn't mean to call you fools. It's just I'm tired and things are not making as much sense in my brain. All right, then I take the cube root of 27, and that'll be 3. So in my first parenthesis, I get the 4x, and I get the 3. Here, the 4x is going to get squared. So 4x squared is 16. X squared, that just means 4x times 4x. This back one, I'm going to get 3 squared, which is 9. The middle term will be these two multiplied. So 4x times 3 is 12x. And now I do my SOAP. Started positive, so same as positive. My O for SOAP is opposite, so it was a positive and went negative, and then AP is always positive. So my answer to this, or my factor of this, will be 4x plus 3 times 16x squared minus 12x plus 9. So that is special forms. They do get bigger, they do get more complicated. There will be times where you'll have a special form and you'll use the special form and then it will have factored down to another special form. Like you can factor it again, or sometimes you'll factor it one time and then like magically another special form will show up. So you just, like difference of squares is the one, like I said, you want to be kind of the most aware of because it's the one that has a tendency to show up the most. But the cube one is never bad to know. But like in a pinch, to me, like difference of squares is the one that's, not that they're not all lovely, but I think difference of squares is the one that's kind of the most common across the board. So I hope that helped with special forms. If you had questions about more special forms or you wanted to see more complicated special forms, you can leave a comment. If you love special forms and you want to like this video, because who doesn't love special forms, you can like the video. You can subscribe to my channel if you would like math videos and that's what you're into. This is the last one I'm doing tonight because I'm very tired. I will follow up next with completing the square and quadratic formula. And I will also probably, if I have time, do a video about the idea of solving for zeros. So right now we're just factoring, but where the step then goes into, and we've seen a little in the class I'm teaching right now, we've seen a little bit of it, but where it goes is actually then solving these and what it means. So, but for now, I'm done. So I hope you have a lovely whatever it is for you right now. And I will see you later.